Hi guys, welcome back to Royanne Study Corner, and I am Royanne. I think everyone knows that by now, anyone who has watched at least a few seconds of my video. And the aim here is to make learning as fun, easy, and the most important thing, I feel, accessible as possible. In today's video, we're going to learn about index notation. I think let's just get into it, and then I'll explain it as we're going through the video. So index notation, this is the final section of that first little topic of physical measurement and units that I talked about that is not explicitly stated on the syllabus, but we still have to know everything about it in order to be able to do anything else. So like we're at the end of our foundation here. So our learning in today's video, we're going to learn about index notation. I think let's just get into it, and then I'll explain it as we're going through the video. So index notation, this is the final section of that first little topic of physical measurement and units that I talked about that is not explicitly stated on the syllabus, but we still have to know everything about it in order to be able to do anything else. So like we're at the end of our foundation here. So our learning objective today is to state units as a product using index notation. This is going to be a very short video. In order to do this, we must know what exactly is index notation. This is a convenient means of expressing derived units. So we learned about derived units last video, which is where we calculated the unit for density and stuff like that. And we use this notation to express units as a product with the sign of the index indicating whether the term is a numerator or denominator. Negative means division, and that means that it's in the denominator, and positive means it's in the numerator. So, simple example here. Meters per second. If you look at that, you'll see m over s, which is how we're used to writing these units. There is a way now to get it in one line. You may have seen it before, but you'd write ms to the -1. If you don't see a power by the number, like in this case, there is no power by s initially. So if there's no power, the 1 is understood. And then s is in the denominator, so if you want to bring it up to the same line as the m, you'll have to put that -1 to show that that s is originally from the denominator. Now let's show another example. Meters per second squared. Now we want to get that second squared up in the numerator, so it'll have to have a negative sign to show that it's originally from the denominator. And we see here that the power is 2, which means that it will become -2. So that's why we have ms to the -2. And I'd advise you all to try these. We have just 3 questions here. You all can try and see if it makes sense to you. Remember, any unit, as long as it's at the bottom, even if you're not expecting to see, like, let's say in example 3 Kelvin, which is a unit for temperature at the bottom, the law still applies to it. No one, let me don't say no one is above the rules, but you get my point. So I told you all, I don't know why I'm clapping so much, but I told you all it will be a really short video, and that is literally it for writing things in index notation. Keep in mind though that this is just one section of that. So I know some people, if they haven't done exponent laws and stuff in math yet, may be a bit confused by this. And if you all want me to do a video to explain why we really put that negative sign when we're moving it up, just let me know and I'll do that. So thanks again for watching the video. I hope you all enjoyed it. I hope you all understood how easy it is if you don't think about all of like the why that you have to do it, how easy writing units in derived, why am I saying derived? Writing units in index notation is. Thanks for watching again, and I will see you all next video. I forgot what I usually say. Be safe and remember to please be kind to yourselves. Bye.